Good morning. We're talking today about the derivatives of inverse functions. We're going to work through this first example to see if we can discover how the relationship between the derivative of a function and the derivative of its inverse function are related. Okay, so first we're going to graph x squared with x is greater than 0. So you got 0, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's x squared. 1 to 1. That means can you draw a horizontal line, crosses once. Okay, and sure enough, if I draw a horizontal line, it's only going to cross once. Okay, so we don't need that in there. Let's get rid of the mess. All right, so 1 to 1, and that proves that it's a function. He said, is there a point on the graph of f where the x-coordinate is 3? Yep, we got that. So let's go back to green. What is the y-coordinate? Well, 3 squared is 9, so f of 3 equals 9. Now it says find the derivative. Now be careful of notation. Derivative, inverse. You have to read carefully. So the derivative of f of x is equal to 2x. They want the derivative at 3, so f prime of 3 is equal to 2 times 3, which is 6. Now it says find the inverse. So you switch your x and y's. You take the square root of both sides, and it tells us we're supposed to restrict as necessary. Well, this was only half a graph, so this is only the positive root. So let's draw that on here. It goes this way. See, when this is 4. 1, 2, 3, 4. 5, 6, 7, 8, 9. Okay, so there's the inverse. Is the inverse 1 to 1? Yes. Or draw the horizontal line. Only crosses once. Vertical line shows that it's function. Sorry, I lied to you up there. Horizontal line shows you that it's 1 to 1. All right, now find. And 1 to 1 means that you can find an inverse that's a function. Find f prime of x, so the derivative of that, let's do this, f inverse prime is 1/2 x to the negative 1/2, which is 1 over 2 square roots of x. Okay? On what point on the inverse corresponds to 3, 9? Well, remember on inverses you flip-flop your x and y's. Now, it says evaluate the inverse function derivative at 9. Okay, so you plug it in here, you get 1 over 2 times the square root of 9, which is 1 over 6. They want us to compare these two answers. Okay, they're reciprocals. Good thing to know, which is going to lead us to today's lesson. This is just another example of the same thing. I don't want to do that. You can do that one on your own and check your answers. Okay, so here, the derivative of an inverse. This to me is really confusing. This makes more sense. But some of it I just think through it's logical. Okay, it's the reciprocal of the derivative of the value on the inverse. So I was just confused. Think of this, f of a is equal to b, then f prime of a is equal to m, all right? So f inverse of b is equal to a. Your x and y's flip-flop. So the derivative at b is the reciprocal of the derivative at a. So let's work some problems. It'll make more sense. We'll come back and talk to that when we get done. Okay? It says find the inverse derivative at 3. So the thing to remember is 3 is x on inverse is the y on function. Okay? The x on the inverse is the y on the function. The problem is that first example we did, you had y equals x squared. Finding the inverse was easy. This one is not so easy. If I switch them, you get x is equal to y squared plus 3y minus 1. And I can't solve for y easily. So we use this technique to get to the answer. All right. So 3 is the x on the inverse. It's the y on the function. So I end up with x squared plus 3x minus 1 and set it equal to 3. Okay? Step 1. Set f of x equal to the y value. And now solve it. So I get x squared plus 3x minus 4. That factors x minus 1, x plus 3. No, plus 4. Right? Because you got a positive 3 in the middle. So I end up with x equals 1 and x equals negative 4. Well, my domain says x is greater than 0, so I can throw this one out. Not because it's negative, but because it's out of the domain. All right? Now, find f prime of your x value. So the derivative of this, f prime, is equal to 2x plus 3. F prime of 1 is equal to 2 plus 3 equals 5. Now, remember the 1 on here is the x on the function. It's the y on the inverse. Okay, so the ordered pair, 3, 1 is on f of x. 1, 3 is on f inverse of x. They want the derivative of the inverse at 3. It's going to be the reciprocal of that. F inverse derivative of 3 is equal to 1 over 5. And that's your answer. Okay, so there's a method here. You set your function equal to the x value they gave you, solve for x, find the derivative of the function, plug in your value, take the reciprocal, gives you your answer. Okay, so let's do another one. I have the cosine of x. This is the y value on this function. So the cosine of x equals root 3 over 2. They're looking for an angle between 0 and pi, where the cosine is root 3 over 2. So I believe that's pi over 6. Now we take the derivative of the function, and you get negative sine of x. Take the derivative at pi over 6, and you get negative sine of pi over 6, which is equal to negative 1/2. So the relationship to what I'm looking for, the inverse function, the derivative at root 3 over 2, is the reciprocal of that, which is negative 2. No, mind you, it's still negative. It's not the negative reciprocal. It's just the reciprocal. Okay? So this and this are related. Just like up here, 5 and 1/5. Let's do one more. Okay? This is the y value on that function. So you set the function equal to the y value, solve for x. So you square both sides. Okay. Then you have x squared minus 5x minus 24. It factors x minus 8, x plus 3. So x equals negative 3 and x equals 8. There's my domain, so I throw this one out. Find your derivative. 1/2 x squared minus 5x plus 1 to the negative 1/2 times 2x minus 5. Don't forget your chain rule. So now I got to do f prime of 8, which is 2x minus 5 over 2 times the square root of x squared minus 5x plus 1. You plug in 8 and you get what? 16 minus 5 is 11. And this is what? 64 minus 40 is 24 plus 1 is 25. Square root of that is 5 over 10. So now my inverse function derivative at 5 is equal to 10 over 11. Okay, see how they're related again? It's a method, practice. Okay, now, the table below gives values of functions and their first derivative. Select values of x. The functions f and g are not inverses, okay? Write an equation for the line tangent to the graph of the inverse of g. So that's not in the table. At x equals negative 2. Okay, so this is telling me that negative 2 is the y value on g. So you come down the column of g, you find negative 2. Here's the x value. Okay, the derivative, of g at 3, let's erase that, that's just a mess. Okay, the derivative of g at 3 is equal to negative 5. So the derivative of the inverse at negative 2 is negative 1/5. So that's the slope of my line. This is the x on my line. This is the y on my line. So you get y minus a negative 5 equals negative 1/5 x minus a negative 2. Because they wanted it to the inverse. Let's do it again. Tangent to the inverse of f. Remember, that's not in the column. This is the x on the inverse. It's the y on the function. So you go down f, you find 1. Here's the x value. Let's change colors so we don't get confused. All right, so you need the derivative of f, at 1. The derivative is equal to 4. So f inverse derivative at, I'm sorry, this should be a 2. At 1 is equal to 1/4. All right, sorry, let's do this again. So this is the y value on here. There's the x. That's the derivative. So the derivative at 2 is 4. On the inverse, the derivative of 1 is 1/4. This is the x value on the inverse. 2 is the y value on the inverse. So y minus 2 equals 1/4 x minus 1. Okay? I hope that helps. Listen to it one more time. See if it makes sense. Practice is the key.